Hello everyone. In this video, we are going to see bit operations for competitive programming. Bit operations are really important for competitive programming as it works on bits. It will take very less time rather than other operations. First operation is AND operation. The AND operation on x and y produces a number that has 1 bits in position where both x and y have 1 bit. For example, here you can see the 0 0. So output comes 0. The both bits are 1 and 1, so outcome 1 comes as 1. The next is input is 1 and 0, so outcome come as 0. If you remember the truth table of AND, then it will easier you to understand. So I am assuming that you have a prior knowledge about the logic gates of AND or XOR like that. So this is the example of 22 and 26. You can see that the binary number of 22 is this one and for the 26 is this one. As soon as we perform the ANDing operation, the answer will come as 18. So where this AND operation is mostly used, you can use this ANDing operation to check whether the number is even or odd. For all odd numbers, the last bit is always 1. So suppose let's take as you can take 1, the binary of 1 is 1, then you can take as 2, 2 is 1 0, 3 is 1 1, then check for 4, 4 is 1 0 0. Okay, then for 5 you can see that for 5 1 0 1, for 6 it is 1 1 0, and last one for the 7 it is 1 1 1. So you can see that for every odd number it gives the last bit as 1. So here only 1 bit, so there is no we can't differentiate there. For 3 you can see that 1 1, the last bit is 1. For 5 the last bit is also 1. For 7 the last bit is also 1. So you can assume that if you want to check the whether the given number is even or odd, then you can just AND with 1, and if for example means for this one 3, you can AND with this one with 1. So it will give you output as 1 for the 3 because it is a odd number. If you AND the 4 with 1, then it will give you output as 0 because you can see that one ANDing operation and 1 and 0 is 0. So if ANDing operation of given number and 1 is 0, then you can assume that the given number is even or else the given number is odd. So for that you can use this AND operation. And why you need to use this operation? Because you mostly use it suppose your number stored in x, then you can use that x modulo to equal to 0 or not equal to 0. So why use AND operation? Because the modulo operation takes too much time for the conversion than operation. But as you work on bit operation, it will take very less time to figure it out whether the given operation means it will figure it out and complete your operation very quickly. It doesn't take too much time. So for that you need to work on bit operations, and for checking even and odd you must use this AND operation only. So it will help you to reduce the time complexity and increase your performance. The next operation is OR operation. The OR operation X or Y. The straight line which is lie on above the enter is OR operator, produces a number that has 1 bits in position where at least one of x and y have 1 bits. So if you remember the truth table for the OR operation, then you can easily relate this one. Truth table is 0 0 0, then 0 1 1, 1 0 1, and then 1 1 1. So this is the truth table for the OR operation. So you can see that for the 0 0 the outcome is 0, for the 1 1 output is 1, for the 1 0 also output is 1. Means any one bit is 1, then it will give you output as a 1. But for AND operation, the both bits must be 1 to give the output as 1. This is the condition. Okay, so let's come to our OR operator. So here we take example as 22 or 26, and above we take a same example and perform an ANDing operation, and it will give output as 18. But you can see that here output is 30, as it is OR operation on the given digits. So let's move to the next operator, that is XOR operator. So XOR operator is operator where two bits are not same, then it will give output as 1, and if two bits are same, then it will give output as 0. So let's take quick look on the truth table so you can easily understood. Give me a second. So here is the truth table, and for 0 0 it will give 0 0 1 1 1 0 1, and for the 1 1 it will give output as 0. So you can see that for the same bit it is output is 0, then again for 1 1 is same bit, so output is 0, 1 0 output is 1, 0 1 for the alternate bit it is giving output as 1. So here we take a same example, and one more thing, OR operation is means upper arrow type sign. You can find it on the by pressing shift and 6 number key on the alphabetical or above the row alphabetical keyboard. So you can press shift key and 6, you will find this operator for XOR operation. So let's move to our next operation, that is a NOT operation. NOT operation basically it will just reverse the all bits in the number. So suppose you have a number that is x is equal to 29, so its 29's representation is 0 0 0 up to this here, and then 1 1 0 1 1 1 0 1. So NOR operator will reverse all bits. That's it. The work of NOT operation is that much only. So next part is bit shifting. This is a very important part to means double one number or reduce the number by half. It will play a crucial role in your programming. So for the left shift you can use this sign, 2 times less than sign. For the left shift it will append a 0 on the right hand side of the number, and for the right shift you can use these two great